Hi, I'm here at a bottling plant with Darren, who's a senior lab technologist. Darren, what is the significance of acid-base chemistry in the beverage manufacturing process?
It's very important in the beverage process. We have water, we have syrup, we have our finished product, we have wash solutions. We need to know what the strength levels of all the various things I just described are and whether they're in spec. And the way to do that is to take known strengths of acid or bases and titrate it against it in order to determine what the concentrations or strengths are.
Well, what about citric and phosphoric acid? What are the importance of those?
They're very important. They are key flavoring components to colas or flavored beverages. For colas, the phosphoric acid, and root beers, they also have phosphoric. Those are key flavoring components. It adds sort of the bite or the sharpness to it, as well as it's a limiting factor for microbial growth. So it maintains the stability of the product.
How can I tell if an acid or a base is present in this pop? Well, I guess I could read the label, but let's go to the lab instead.
Robin and I are going to perform diagnostic tests on acidic solutions and basic solutions. We will use these test results to establish an empirical definition for acid and basic solutions.
That will help me determine whether or not acids and bases are present in this beverage, right?
That's right. Now, for our acidic solutions, we're going to use lemon juice, and for our basic solution, we're going to use household ammonia. Now, on this pot plate, we filled this side up with lemon juice, and we filled this side up with household ammonia. So, Robin, go ahead with the litmus test.
Okay, if I put red litmus in with the lemon juice, it stays red. And if I put blue litmus in with the lemon juice, it turns to red.
Okay, what about the household ammonia?
I'll put red litmus in the ammonia, and it turns to blue. And blue litmus in the ammonia stays blue.
Good. All right, the next test we'll use for an indicator is bromthiamyl blue.
Okay, I'll put a drop of bromthiamyl blue into the ammonia, and it's blue. And in the lemon juice, it's yellow.
Okay, next indicator, phenolphthalein.
Phenolphthalein is colorless in lemon juice and pink in ammonia.
All right, so we're done with these tests. Let's move on to the next set of diagnostic tests, taking the pH. All right, let's put the pH probe into the lemon juice. What should the range be?
It should be somewhere below 7 because it's acidic.
Right, and it is. We can see that from the meter. Rinse it off, and you can put it into the ammonia. What should the range be?
It should be above 7.
And it is, because it's a basic solution. All right. Now, next diagnostic test is taking a look at neutralization. Acid and base solutions neutralize each other. So, let's put the probe into the lemon juice, and you can pour some household ammonia into the lemon juice. It's reading now in the acid range. If we add the household ammonia, you can see that we've neutralized the solution, and now I've even gone further and changed it to the basic range. So we've neutralized the solution first. Good. Now, next test is looking at whether we can determine an acid-base property based on taste. What does lemon juice taste like?
It tastes sour.
All right. Now, how about household ammonia? What does it taste like?
I've never tasted ammonia.
It's poisonous. You wouldn't want to taste it. That's wise. Now, base solutions, if it was safe to taste, would be bitter. For example, cocoa. Baking cocoa is bitter. It is a base. There's a base component in it. Now, another property of bases that acids don't exhibit is the feel. What does soap feel like?
Slippery.
And there is a base in soap. All right, so now, when you're in the lab, even though you're sure of the contents of the materials, you never want to taste anything or feel anything. And that's because common household substances can be toxic and corrosive. Okay, next test, carbonate. For our carbonate, we're going to use baking soda, sodium hydrogen carbonate. Would you add it to the lemon juice, which is our acid solution?
Okay.
What do you notice?
It's starting to bubble and fizz, so it's reacting.
All right, now add the baking soda to household ammonia. What do you notice?
Nothing's happening.
Okay, next test. We're going to take an active metal, and we'll use magnesium as our active metal. Place this active metal into our acid solution, our lemon juice. What do you notice when you put the magnesium in?
Bubbles and fizz. It looks like it's starting to react.
Good. All right, now we'll do the same thing with household ammonia. Put the strip of magnesium in.
And nothing's happening.
All right, good. So now, these diagnostic tests, we can use them on your beverage. Here it is. Which one will you use?
The litmus paper would probably be the easiest test.
Okay. So take a sample of your beverage, put it on the litmus paper.
Okay, I'll put it onto the red litmus first. And stays pink.
Okay.
I'll put it onto the blue. If I shake the extra off, it turned to pink.
Good, so we can see it's changed color. So what does that confirm?
That this must have acid in it.
That's right, according to the litmus test. All right, so now we can use these diagnostic tests that we've just performed to establish this empirical definition of acid and base solutions.